The proposed solution isn't perfect, but could help buy us some time, researchers say. Astronomers are exploring solutions to mitigate climate change, one of humanity's biggest challenges, by using some tiny players, dust particles. In recent research, they propose mining, scooping, and blasting dust from the moon's surface and placing it between Earth and the Sun, where the newly placed clouds would shade our planet for a few days before solar wind and radiation pressure disperse them. In a year, researchers say, such dust shields could reduce earthbound sunlight by 1.8%, which falls within the range needed to slow our planet's rising temperature. Creating such a shade would require 22 billion pounds, 10 billion kilograms of dust per year, which is roughly 100 times more mass than humans have sent into space to date, the authors wrote in their study. How many launches would that take? From Earth, about 700x more launches than we've done to date. Benjamin Bromley, an astrophysicist at the University of Utah and the study's lead author, told Space, but from the moon we envision an electromagnetic launcher whose specifications are not yet determined. The astronomers are suggesting that dust particles could be used to block sunlight before it reaches Earth. This proposed solution is not new. In 2012, astronomers ambitiously considered pushing the largest near-Earth asteroid, the 22-mile-wide, 35 kilometers, 1036 Ganymede, between the Sun and Earth, to both create a dust cloud and gravitationally hold it in place. Astronomers have also explored expensive and resource-intensive geoengineering projects like gigantic screens and reflective mirrors to cool Earth. The newly proposed solution uses dust readily available on the moon's surface, so it would be simpler, cheaper, and more effective compared to previous methods, researchers argue. Launching from the moon requires much less energy than launching from Earth because lunar gravity is just 1/6 as strong as that of our planet. The team analyzed the sizes, shapes, and compositions of different particles like coal dust, porous glass, sea salt, and moon dust. They also compared the effectiveness of launching dust from a platform in space to blasting it from the moon's surface. Once placed at or near the first Lagrangian point, or L1, a gravitationally stable spot between the Sun and Earth, about 1 million miles, 1.5 million kilometers from our planet, the team used computer simulations to study how long these particles would hover. For example, in their modeling work, researchers launched a test particle from the moon's northern pole to an orbit close to L1. They found that the particle launched at 1.7 miles per second, 2.8 kilometers per second, spent a total of 5 days in front of the Sun before being dispersed. The team concluded that launching moon dust at about 1.9 to 3 miles per second, 3 to 5 kilometers per second toward L1 would be the most promising strategy, shading Earth for the equivalent of up to a week every year. For such an effort, they estimated an energy equivalent of about 2,500 Saturn V rocket launches would be needed. It is amazing to contemplate how moon dust, which took over 4 billion years to generate, might help slow the rise in Earth's temperature, a problem that took us less than 300 years to produce. Scott Kenyon, an astrophysicist at the Harvard-Smithsonian Center for Astrophysics and a co-author of the latest study, said in a statement. The researchers say their study only evaluates the potential impact of this approach, as it could be an option in addressing climate change if what we need is more time, Bromley said in a different statement. The logistical, legal, and technological challenges of implementing such an effort are not touched upon in the study. One of the important unknowns, for example, is the impact of repeatedly placing huge amounts of dust at or near L1 orbits, which is home to NASA's Solar and Heliospheric Observatory, as well as the Deep Space Climate Observatory. In most scenarios, dust would steer clear, but we have not checked in detail, Bromley told me. As we stand on the precipice of 2025, the drumbeat of climate urgency grows louder, echoing through scientific halls and policy chambers alike. The lunar dust shield, once a fringe astrophysical musing, now finds itself woven into the broader tapestry of solar radiation management, SRM strategies, bold interventions that dare to tweak the heavens to preserve our earthly Eden. Recent years have witnessed a surge in support for such geoengineering, with astronomers and climate experts alike advocating for rigorous exploration, not as a replacement for slashing emissions, but as a desperate bridge to survival. Imagine the audacity. Startups like Make Sunsets, born in the crucible of Silicon Valley innovation, have already lofted balloons laden with sulfur dioxide into the stratosphere, mimicking volcanic eruptions to reflect sunlight and cool the globe. By late 2024, they've deployed over 90 such vessels, selling cooling credits to offset warming equivalent to millions of trees, a poignant reminder that private enterprise is stepping where governments hesitate. Yet, space-based solutions like our lunar proposal hold unique promise, sidestepping the perils of atmospheric tinkering. While stratospheric aerosols risk ozone depletion and erratic rainfall potentially parching India's monsoons or flooding vulnerable coasts, the moon's dust offers a cleaner, more controlled veil. Proponents, including visionaries like Istvan Shapudi, argue that redirecting just a fraction of global military budgets could fund these celestial shields, whispering, if we spent 10% of what people spend on weapons in a year, for a few decades we could easily do this project. Alternatives emerge too. A tethered sun shield at L1, proposed in recent studies, could use a lightweight structure to block sunlight with far less mass than dust clouds, potentially revolutionizing efficiency. But oh, the heartache of uncertainty. Critics warn of moral hazards, where such tech might lull us into complacency, delaying the fossil fuel reckoning we so urgently need. In this cosmic drama, ethical storms rage. Who wields the thermostat? Billionaires like Bill Gates, funding SRM research since the early 2000s, or nations like India, poised for unilateral action amid scorching heat waves? Governance lags woefully. The U.S. White House's 2023 report calls for transparency and international cooperation, yet outdoor experiments face bans in places like Alameda, where a sea salt mistrial was quashed over health fears. Over 530 scientists and 2,000 GOs demand a moratorium, fearing geopolitical chaos. Picture Putin or Musk dictating the skies. Still, voices like Catherine Rick implore, shunning this research is riskier than studying it, urging us to probe deeper with computer models and small-scale tests. As an astrophysicist, my heart swells with both awe and trepidation. The moon, that eternal muse, isn't just rock and regolith. It's a repository of hope forged in the fires of creation. We've scarred our world in centuries. Now let's mine the stars for redemption. But heed the warnings. SRM buys time, not absolution. Let us rally scientists, policymakers, dreamers to forge norms that safeguard equity and ecology. For in the dance of dust and light lies not dominion, but stewardship. Our planet weeps, the cosmos calls. Will we answer with wisdom, or let hubris eclipse our chance at dawn?